Students, for those who read in class 10, there is a first lesson called force, and today I'm going to tell you a few formulas that are used in that chapter, especially the main formulas, and I'm also going to tell you when to use those formulas in order to get the answer. So there are three main formulas. One is for the force, or it's also called the gravitational force between two heavenly bodies, and it is used, the formula is G m1 m2 by d square. This is the formula to calculate the force, and it is used when these things called the universal force is mentioned in the question. Find universal force, and the distance between the two heavenly bodies is given, and masses are there given, and if the question asks you to find the force, then we use this question. Here G is universal gravitational constant, and you have to write down this value yourself, is 6.67 10 to the power minus 11 Newton meter square per kg square. This is the value of the universal gravitational constant. M1 and M2 are mass of bodies. D is the distance between them. And F is force. So whenever force is asked in the question, and whenever these materials, among these four variables given to you, 1 2 3 4 variables, whenever three variables are given to you and you have to find the next one, always use this formula. This is the chief formula that is used in this chapter. Okay, and next formula that we use is to find the acceleration due to gravity of a planet, and at that time it is represented by G, and the formula is G capital M by R square, or we can also use sometimes G capital M by R plus H whole square. So when to use these two formulas? Okay, I'll write the notation to you, where M is mass of heavenly body, R is radius of heavenly body, and H is height. So if radius of heavenly body is given, example, object is 30 meter from the surface of the earth, such question is given, then at that time you need to apply this below formula, because height of object is also given. You need to add the height to the radius in order to find the acceleration due to gravity at that height of 30 meters. So if height is also mentioned, then you use below formula. If height is not mentioned, only you need to calculate the acceleration due to gravity at the surface of some heavenly body, be Earth or Jupiter or Mars or Saturn, doesn't matter. So this formula is used in finding the acceleration due to gravity. So these two are the chief formula that are used in this lesson, and they all have particular units. You need to remember that force, if nothing is mentioned in the question, then force is always measured in Newton. So if you see something on the back of the question Newton, then usually that will be the force or the weight. Only these two quantities have Newton mentioned on the back of there in this chapter. So either the force is measured in Newton, or it might be the weight as well. So question will clearly mention you if it's the weight. And next, acceleration due to gravity unit is meter per second square. So answer should come in meter per second square, answer should come in Newton. If acceleration due to gravity is the question given to you, use this formula. Choose one among these two. This is only if the height is given. And if the question talks about force only, then force always you use this formula. Except these two formulas, there are some other formulas secondary formulas used in this chapter, which play an important role in taking out the answers. Example, we need the formula of weight of the body. Weight of the body is given by cap small m, mass of the body, into acceleration to gravity of that planet. If it's of Earth, it's 9.8, but variable in case of Earth as well. It's different in pole, is different in equator. So m is mass of object here, and g is acceleration to gravity. So sometimes question is, first you have to apply this formula and find g, and then you have to calculate the weight. Or sometimes weight will be given to you, mass will be given to you, you calculate the g and use this value here in order to calculate some values here. The g is always there, m the arma, one value will be given to you and one you have to calculate. So such questions are usually asked in your questions. In your next formula is g by z dash is equals to r plus h whole square by r square. Now when to use this formula? It is a very very important formula. Now when to use this formula is a problem to many, I guess. So whenever question does not mention about mass of heavenly body, it does not mention about the distance, it only talks about the radius and acceleration due to gravity at certain height. So at that condition only you use this formula. So in this formula, this small g is acceleration due to gravity at surface. It might be at, usually the question is of Earth only. So acceleration due to gravity of Earth. G dash is the, or GO I mentioned on the derivation part. So G dash is the acceleration due to gravity at height, certain height. R is radius of heavenly body, of what you are measuring. If it's of Earth, then it's of Earth. It might be of Jupiter. And h is the height from surface. So if the height is given from the surface, then you use h. Sometimes what is given directly, r plus h is added and given to you. Example, r plus h can be the distance from the center to the heavenly body. So in that case you always apply only you write here d instead of this. Instead of this value you can write d only when distance is from the center distance between the center of the heavenly body and the object is given. Else always you use r plus h. So these are the chief formulas that are used in this lesson. Another formula is of depth. That depth formula is not that asked in exam.